Hey gang, today we're going to be doing an overview of some exponent rules that you may or may not remember from the past, but you definitely need them to be successful in our upcoming units in algebra. So our first rule is, in general, for any number x and any integer, n, x to the negative n equals 1 over x times 1 over x n number of times. So you take the base, which is x, turn it into its reciprocal, and then multiply that reciprocal times itself n times. The negative disappears once you do the reciprocal of the base. So given the rule above, we're going to write the following in expanded form and evaluate the following. I'm not worried about you guys writing in expanded form, so we're going to skip that. We're just going to rewrite it with a positive exponent and then evaluate if necessary. So this 8 to the negative first is telling us to do the reciprocal of the base. So 8, its reciprocal is 1 over 8, and it wants us to do it one time, or to the first, and anything to the first is just itself. So our final answer is 1 over 8. Next, we have 2 to the negative fifth. So again, to get rid of the negative, we take the reciprocal of 2, which is 1/2, gets rid of the negatives, so makes that 1/2 to the fifth. And then 1 to the fifth is just 1. And 2 to the fifth, we can use our calculator if we're not sure. We would do 2 raised, that's this button right here if you didn't see it, to the fifth equals, and it's 32, which makes sense because 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 one more time is 32. Next one, again, we get rid of the negative by rewriting it as 1 over 6. Tells us to do it one time. So our final answer is just 1/6. So this is a very important rule when we get into looking at exponential functions. Well, we will be working with exponents a lot. So you guys are now going to try numbers 4 through 6 on your own. You can pause the video, check in with me, and then pick it back up. Okay, so in general, for any numbers x and y and any negative integer n, x over y to the negative n is y over x times y over x times y over x n times. So similar to the last rule, in order to get the negative away, to get rid of that negative exponent, we take the reciprocal of the base and then multiply that by itself n times. So again, we're not going to worry about the expanded form. We just want to rewrite it without a negative exponent and then evaluate if needed. So 2 over 5 to the negative first is just going to be 5 over 2 to the first, or just 5 over 2. 2/3 to the negative fourth is going to be 3 over 2 to the fourth. 3 to the fourth is like 9 times 9, because it's 3 times 3 is 9, 3 times 3 is another 9, 9 times 9 is 81. And 2 to the fourth is like 4 times 4, so that's 16. So our final answer is 81/16, which cannot be simplified, so I'm going to leave it that way. And then 4/3 to the negative third would be 3/4 to the third, which is 3 times 3 times 3, or 27, over 4 times 4 times 4, or 64. Okay, so these are very simple rules, but probably something you wouldn't have expected on your own without being introduced to it. So you guys are going to now try the next 3 using that same rule. Check in with me before continuing the video. Okay, next we have a multiplication rule. When multiplying like bases, simplify by adding the exponents. Try the following. So here, if I were to write this out, I would get x times x times x times x times x, all being multiplied together for this x to the fifth, and then x times x times x for the x to the third. Putting that all together, I'm multiplying 8 x's, so that's x to the 8th power. So the rule again is to simplify multiplication of like bases, you just add the exponents. So in number 16, we have a similar case, but now we have other bases to consider that don't have exponents, the negative 3 and the 5. So we just multiply those together. We get negative 15. Then we take the x to the fourth and the x squared, keep the base of x, and add those exponents. We'd get x to the sixth. Because like I showed you in number 13, if I were to write them out, I would have 4 x's being multiplied and 2 x's being multiplied together for a total of 6 x's being multiplied together. Okay, so again, you're going to try numbers 14 and 15, and then 17 and 18 on your own. Again, check in with me to make sure you're getting them right before moving on to the rest of the video. Okay, similarly, when you're dividing like bases, you're going to simplify by subtracting exponents. Let's try the following. So here we have n to the 7th over n to the 3rd. And again, if I were to write that out, it would be n times n times n times n times n times n times one more n all over n to the 3rd, which is n times n times n. When you have a number over itself and you divide, they kind of cancel out because you're getting a value of 1. And when you multiply by 1, it doesn't change the solution. So our final answer is n to the 4th. So again, I could have just done 7 minus 3 and kept the base of n. So similarly for number 22, we have m as our common basis, but 12 and 4 do not have exponents. So this is a division problem, so we're going to do 12 divided by 4 and get 3. Then subtract our exponents, m stays, 7 minus 5 is 2. So it's 3m squared. So again, you're going to try some problems on your own and check in with me when you've got them complete to be sure that you're getting them right. Our last rule is that when you're raising a power to a power, you're going to simplify by multiplying the exponents. Let's take a look at two examples together before you try some on your own. So in this case, number 25, I have x squared to the 5th. So that's like doing x squared times x squared times x squared times x squared times x squared. And we know when we're multiplying those out, we can add the exponents from the previous rule. But this x squared would be two x's being multiplied together. And then this one would be 2 more, and this one would be 2 more, and this one would be 2 more, and this one would be 2 more. So that's going to give us x to the 10th, which I could have found just by multiplying the 2 and the 5. So in number 28 rather, I have to first apply the square to the 12, and then apply the rule to the 3 and the 2. Because that 12 doesn't have its own exponent, the exponents do not have to be multiplied together. So we have 12 squared, which hopefully you guys all know is 144. That's 12 times 12. And then y cubed squared is going to be y to the 6th because 3 times 2 is 6. So one last time, you're going to try some problems on your own. Check in with me before moving on to your exit tickets to be sure that you're getting all of these answers correct.